Okay, we're going to look at something called special triangles. Special triangles. And sometimes they ask you to do trigonometric questions, and they say you're not allowed to use a calculator. Well, whenever they say you can't use a calculator, it's time to pull out your special triangles. Now, I'm going to show you one. This is a special triangle. If I make an equilateral triangle that's 2 units by 2 units by 2 units, I'm going to split the 2 into 1 and 1. 1 plus 1 is 2. There's the bottom. And I'm going to come straight down here. Do you know if the sides, if this is 2 by 2 by 2, all the angles will be 60 degrees. It's called an equilateral triangle, and the angles are 60 degrees. But if I dropped a line straight down like this, it will bisect this side into 1 and 1, and it'll cut that 60-degree angle in the top into an angle of 30 and 30. Now, I like doing this because I didn't have to memorize. All I had to think of is an equilateral triangle of 2, and I just built the special triangle I need, which is just this side of it here. Now I can use Pythagoras to find the vertical side of the triangle. It's the square root of 2 squared minus 1 squared. 4 minus 1 is 3. This distance by Pythagoras is root 3. So there's my special triangle. That's one of the special triangles. Whenever they say without a calculator, and they ask you to figure anything to do with 30 or 90, this is 90 degrees here, not because this is a perpendicular line. You sketch this triangle down so that it looks just like this. Now there's one other special triangle that's real important. It's a 45-degree triangle, and all you have to do is go 1 along, 1 up, and then by Pythagoras, the square root of 1 squared plus 1 squared, the square root of 2 goes on the long side. So there's your 2 special triangles. Now what they'll say, you can determine all the sine, cosine, and tangent of 30, 60, and 45 using these triangles. And all you've got to do is the same things we always do. Just name the sides adjacent, opposite, and hypotenuse, and fill out the sine, cosine, and tan. If you have these pictures, you're allowed to just write it down. So you could fill out this chart right here. Watch how I do this. First, I know SOHCAHTOA. Sine is opposite over hypotenuse. So let me just do a few of these. Say the sine of 30 degrees. You go to the 30-degree triangle. You put your thumb on the 30 degrees and go opposite over hypotenuse. Well, that's 1 over 2. As long as you have this picture, you can write down the sine of 30 is 1 over 2. Let's try another one. Say they say the tangent of 45 degrees. Well, you go tangents opposite over adjacent, go to 45 degrees. Now, don't just put 1. They don't like that. They want to see that you're using the triangle. So opposite is 1, adjacent is 1, tangent is opposite over adjacent, so 1 over 1. The tangent of 45 degrees is 1 over 1. What about let's try the tangent of 60 degrees. Well, we'll go to 60 degrees. There it is. But the tangent, root 3 is opposite. 1 is adjacent. And opposite over adjacent, it's good to write root 3 over 1. If you press tangent 60 in your calculator, it'll just say root 3. But if you're using this special triangle, the examiners want to see that you went root 3 over 1, opposite over adjacent. So you just use SOHCAHTOA, but you go to the angle and then just do whatever it says. If it says adjacent over hypotenuse, go 1 over root 2, like that. And that's how you do it. That's called your special triangles. Let's see what's coming in the next video. We're going to do an exam question. So if you want to see an exam question done, you can look at the next video.